Okay, so we're gonna build off of something we did in class the last few days. I guess we'll call this playtime. It's gonna have a little go at trying to build our understanding about solving equations. So here's the model. You can pause the video, and I hope that some of you can immediately say what this x value is and what this one is. I'm just going to continue. So at any time I pose a question, hit the space bar, give it some thought. All right, so these answers are 5 plus or minus the square root of 32 over 3. And with practice, you can get that with ease. All right, so where did it come from? Came from the, let's see, yep, can see this. X equals a, x minus h squared plus k model set to 0. Okay, so I don't know why I wrote x equals, but we're gonna get x equals from this. So what do we see? Well, we got to go up 32 units. Okay. And our k value is negative 32. All right, that's the y value of the vertex in the graphing form. Okay, that's good. And I think we can see that if something minus 32 equals 0, then that something has got to be 32. So it makes sense to grasp that. And the next time you look at this, you know that that's got to be part of the answer. That process. All right, so now our first step obviously is to move minus 32 to the other side. Okay, it's moved. I guess I'll erase it at this point. Sure looks like something times a squared gets us 32. Let me rewrite that. A times something, I'll box that whole something, equals 32. Well, then we have a, right? It's been, oh, it's a 3, excuse me. It's a 3. There, now I'm finally saying what I want to say. 3 times something equals 32, then what's in here has got to be 32 over 3. So the 3's cancel. So it sure looks like we have that moving to this side of the equal sign. I think I'll write in the entire equation here. So at least it maybe can be seen more easily, right? This is the equation that we're dealing with. Right? And I hope you can see those first 2 steps really easily. Okay, subtraction becomes addition, multiplication becomes division, and that leaves us at the x minus 5 squared equaling 32 over 3. And again, if we want to get at something squared has to equal 32 over 3, we've been dealing with inverse operations. And the inverse of squaring, pause the video, most will make a mistake here. Okay, most will make a mistake. We'll forget about the symmetry of the quadratic. So it's the plus minus square root of 32 over 3. All right, well and good. That leaves us with x minus 5, which tells us that we're looking at x values that are 5 plus or minus the square root of 32 over 3. And I'll put this smack dab in the middle here. It's always good just to take an answer and look at what we're starting with. And I'm seeing all 3 numbers. So if I take the time and put in a little effort, then if I've got something in graphing form, I should be able to 5 seconds to say the roots. That's helpful. Anytime you can do something in a shorter period of time allows you to think about a problem or do something else in life. Solve a problem perhaps in math with a little more time than an SAT or a final exam. It's useful. It's useful. So, and I don't want to, pass up the opportunity to say, look at it even more deeply. And if you do, you got the intersection of 2 graphs. You got a constant, y equals 0, and you got a quadratic. So you've been finding when you're solving an equation like this, you're finding the intersections of 2 graphs. And that is something that we should ponder, because what if we had a different graph? How would we solve this? And then in general, this type of model, how do we solve it? I think we should dive into that more deeply. So let's, I moved this axis. I just, the horizontal axis, doesn't matter where you put it. This is a 5. at a height of 0. This is a 5 at a height of -64. This is a 5 at a height of -32. So the horizontal allows us to say that, oh, so what is that x? We just found it. That x is 5 minus the square root of 33 over 3. And you should approximate that. 32 over 3 is pretty close to 33 over 3, which is the square root of 11, which is somewhere between the square root of 9 and the square root of 16. All right, so we know our answer here is somewhere between 3 and 4. So 5 minus 3 is 2, and 5 minus 4 is 1. So we got an answer here between the numbers 1 and 2. But you want to have a little fun doing that so that you're not just, numbers on there that don't have any meaning to you. And we should check our answer out. And we'll do that with we'll put that answer in for x, and let's put a 3 times this answer minus 5 squared minus 32, and let's do it out. And let's see if we actually get a height of 0. It's important to do that too. Well, it's just nice because I know 5 doesn't work, so we just get rid of it. We get rid of that 5 because we know that gets us -32, and that's not 0. So we don't want those numbers. And I think when you square a positive or a negative, I think the squaring always gets us positive answers, except for that one little square that gets us 0, right? 0 times 0 is 0. It gives us the minimum. That's why 5's a minimum here, because it's acting like a 0. We put 5 in, and so there's geometric significance. So that goes. And we've been practicing squaring a square root, right? With the square root of 5 times the square root of 5 equaling 5. Therefore, the square root of 5 squared is that picture, and it gets us 5. So if I square this, it gets me 32 over 3. Right? Inverse operation has now been used. And I think 3 divided by 3, I don't think I have to do that. And we can see 32 minus 32 is 0. All right, so we've been practicing that in class, and many of you have it down now. And it looks easy. Why? Because you put the effort into thinking about what's going on. I want to encourage that for all the problems we're doing for the remainder of the semester. But, I really didn't want to talk about this. No, well, I guess this one is 5 plus, right? So this is 5. So I guess this distance here is positive, as measured from 5 is positive 33 over 3, right? That's what that distance is. Because if you do that distance, if we go over the square root of 33 over 3 and we square it, well, then we get a 32. I keep saying 33, so excuse this, go back to 32. Okay, I was doing a little approximation before. But if you square it, then you want to go up 32 units, and we square it, we get that, but we gotta take a third of that because we're gonna triple it. That'll get us there. All right, I'm rambling on that. So let's get to where I wanted to go, which is, maybe there's a way to do equation solving for a variety of equations. Maybe even we can look at, I think I got a canned one here. Minus 64 plus 32 doubled x minus 5 over, how about we do the square root of 32 over 3? Let's see how hard this really is. And let's get, because we know that value, right? We know that value. So that value is 5 plus the square root of 32 over 3. That's all inside the square root. And that gets us a height of 0. Right? So I'm going to erase this. I'm going to keep the 0 here, because we're going to solve an equation in a minute. Of course, we can't solve an equation unless we write one. So let's get that out of here. Let's get that out of here. Oh, and I've got minus 64 down here. I think I'm going to make a exponential function, because we've been practicing how to write these exponential functions. Yeah, and I'll get rid of all of this here. All right, and so this height of minus 64 appears to be asymptotic behavior, because if we're doubling in this direction, then we're cutting in half in this direction. And if I keep cutting 32 in half, well, that's 16, that's 8. And if I've got negative 64 and I'm adding these numbers, and that's 4, and that's 2, and that's 1, and that's a half, and that's a fourth. Sure looks like I'm heading to 0. And if I'm heading to 0, then I'm heading to negative 64. Because I'm cutting an initial amount in half as I think right to left. As I think left to right, I'm doubling. Okay. I think we can see that. You know, negative 64 to negative 32 is 32 units up. Negative 64 to 0 is 64 units up. And it appears that that's happening every square root of 32 over 3. Such daunting numbers, but are they really so daunting? Well, first we got to get the equation, right? And we've been practicing this. So this is minus 64. How do I get to minus 32? I go up 32. Okay, next time I don't go up 32, do I? No, the next time I go up negative 64 to 0, up 64, right? And my first x is 5. So there's my x minus 5. And I'm changing by 5 to 5 plus root 32 over 3. And there's my root 32 over 3. And we're practicing that. We're practicing that. Of course, we're going to turn this into E notation after. You know, I'm going to show you why that's true. But, oh, I digress. Excuse me. Let me go back to this. All right. And if that's still hard for you, then you got to go back to the videos where we build exponential functions. It's on the YouTube channel somewhere. You got to find how do you do this process. So look up graphing exponentials. All right. Oh, wait a minute. I remember now. We're trying to set this to 0 to see if we can actually get this answer. Yeah, because that requires some techniques of equation solving. And I think we've already established some techniques of equation solving. So what are we going to do here? Let's see if you can follow. Right, get a little more practice with this. Well, I think minus 64 is now the distance we want to get from this model. So let's bring it over here. And I'll erase this as we go. Multiplication by 32. I guess we got to divide by 32. And that gets me 64 over 32. And I got the nice washcloth. There is my 2. So I think I'll erase it here now. Say 2. And I divided by 32. So that's gone. And now we have a function. A basic 2 to the x function. And we've been trying to learn the inverse of that. And some people have it down now, and some people don't. Turns out it's logarithm. Okay, we can check that by putting a 3 in here and getting an 8. And over here, it's not a perfect check, but it's good enough for our purposes right now. And I hope you can see here an 8 gets us a 2. So the inverse of exponential form is logarithmic form. And instead of going from 3 to 8, the inverse 8 to 3. Why did I write a 2? Because it's Saturday morning and I haven't had enough coffee. So let's take care of that right now. Little hazelnut cream in here. Probably pretty good. It is. All right. So here we are. We are now at 2 to the x minus 5 over root 33. What is it? 32 over 3. All right. We don't have to simplify the square root of 32. We can just leave it as it is. So you've got a 2 to the x function. I guess we got to use logarithms. And if we use logarithms, the base is going to show up on the other side. Now, where the heck am I in this process? Did I copy it properly? All right, so that gives me x minus 5 over the square root of 30. I think I've seen that. 32 over 3. That's right. You keep wanting to say 33 now. And that's going to equal log base 2 of 2. And we have been spending months. We introduced this on day 2 of our semester. So I'm hoping 2 months later, you know what that is. And I think most of you do. A few of you still don't, but that's 1. right? Because this is the exponent you put on top of the two to get a 2 to the 1. What's the exponent on top of that 2? It's in the same base notation, it's a 1. So that now leaves us with x minus 5 over the square root of 32 over 3. And that's a function too. We could graph that. You know, my AB calculus kids didn't recognize what kind of function that was. So pause the video and you can think about it. It's a linear function, right? Because you can divide this into that, and you can divide this into that, which is going to get you your favorite mx plus b. Complicated numbers, but that's just a linear function. Oh, I think we can isolate x now. I think division becomes what? Multiplication. And that simply brings it over to this side. And I think subtraction of 5 gives us addition of 5. And that one is plus minus, but in this case, there's only one answer, and it's on the positive side. And boy, that should look familiar from the previous problem we did with the quadratic. There seems to be a pattern here to problem solving. We're going to identify that pattern after we do another problem. All right, so could I make this a logarithm? Yeah, I could. And then I think I'll build it. I think I'll build it. If I build it, they will come. That's what I heard. Right? I don't want any baseball players coming in here out of the walls. All right, so let's build that model. And let's do that separately. And let's just see how hard it is to build that model. And you can try it yourself. I know I have a couple of students in class who will actually try that right now. God bless them. All right, so here we go. Let's do it over here. Let's get an asymptote less than 5. How about an asymptote of 1? And I haven't done this before. This is playtime for me. And I know a couple of points. 5, negative 32. And I also know 5 plus root 32 over 3. I finally said that one properly. Gets me 0. And so we'll build that inverse of growth. Bumpity, right? Probably not drawn to scale at all. Although it wasn't too bad, because I did have a feeling for this. This was between what two numbers, 3 and 4? So, you know, 8 and 9. From 1, 8 units, 4 units. Not too bad. It's actually not too bad. And that's a skill that's useful to have. Okay, so what's this equation? Let's just do it. First y value I see is negative 32. How do I get to a height of 0 from negative 32? I got to go up 32. All right, it's a logarithm with an asymptote of 1. Well, you know, there's always been one sheep in Gill. Then I better have more than one. I don't know what I just said, but that's okay. It's a domain restriction, which we can talk about. I put in a 5. 5 minus 1 is 4. So now I've got 4 divided by 4, which is log 1. Doesn't matter what the base is, right? That's equal to 0. The beneath of the 0 is 1. Okay, so I've just made a 0 times 32. 0 minus 32. Oh, it works and it works. Of course, now I've got to put in what? I've got to put in my next coordinate. And am I running out of room? I'll do it here. So I'm going to drop 5 plus the square root of 32 over 3. I hope this doesn't get to be too much of a pain. It might. Minus 1 over 4 becomes my base. Well, 5 minus 1 is 4. Okay, so that's 4. 4 divided by 4 is 1. So I really get 1 plus the square root of 32 over 3 divided by 4. And I hope that you followed that, because we've been practicing, you know, 2x to the negative, 2x to the 3 minus 4x to the 5, all over 2x to the 2. We've been practicing that distributive division. There is such a thing, because division is a form of multiplication. And let's see. So where am I now? Got to get my thought. Better have a sip of coffee. Got one of those moments. All right, so I think I've got that. And so I guess I'm ready to solve this equation. Boy, what an ugly thing. So let's see what happens if we plug it in. No, let's solve it first. Ooh, let's write it over here and solve it. And we see all the way up, yep, yes. Minus 32 plus 32 log x minus 1 over 4 with a base of, what was the base again? The base was, oh God, ugly thing. 5. Oh no, I'm gonna bring it down to 1 plus the square root of 33 over 3. Lord, divided by 4. All right, gonna go for it. I'm gonna have to do it here. So minus 32 comes over as positive 32. Gone. Dividing 32 by 32 gets us 1. Boom. Well, if I do log and it equals 1, then I've got to change to exponential form, and I've got to do 1 plus root 33 over 3/4, that's all inside, right? Equals x minus 1 over 4. Woo! All right, so this is now moved to the other side as an exponential. This isn't too bad. I got to multiply this by 4. Ooh, so it's actually better. Well, that's going to be 4, and then the 4's cancel, so that gets me 4. Okay, I hope you can see this. Let me bring this down so you can see it better. So 4 times 1 is 4. The 4's canceled, and I get root 33 over 3, divided by 4. No, 4's canceled, right? So I did that, okay? And that gives me, I multiplied by 4, so that really came over, right? That gives me x minus 1. And it sure looks like I can add 1 to 4 and make it 5. Oh, geez, those solving techniques seem to work even with a nasty little square root number involved in it. Boy, that's a big step in the right direction. And it sure looks like I've got the intersection of 2 graphs again. Wow. Understanding the order of operations and understanding inverse operations seems to be essentially to the development of your ability to think mathematically. And the only way you're going to get those inverse operations in your head is to try every problem every day at the board until it becomes something a lot easier for you. And some of you have made tremendous progress in the last 2 weeks and are starting to see this process. So let's generalize this process. If I'm not mistaken, we have taken several functions with a little multiplication of those functions and a little bit of constants, and we have been setting those to 0. And it sure looks like if I can make, well, actually, I'm talking about graphing right now, so let's just talk about graphing. So that y equals, well, if I can make this function equal 0, then I have 0 times m plus c. Looks like I've got c. And what makes our function 0 over here? Well, this is, I shouldn't have used this one. I should have used the exponential. Right? I've lost the exponential model. So I'm just going to backtrack and say, this is a product. Making products 0 gives us some useful and quick information. So if I can make f of x 0, then I know that y of 0 is c. And if I can make this function equal 1, then I know y of whatever makes it equal 1, some number, right, is going to give me m plus c. And we can use that everywhere when we're graphing. And we're going to be graphing sinusoids soon. We're going to be graphing e to the x and ln of x functions. And that's it. That's it for our semester. We're not going to push it more than that. We're going to give you time to move into those for, a month and a half of study. But it's going to come your way right after the break pretty quickly in that first week, so that you can at least get a month, at least 4 or 5 weeks of trying to get an understanding of those. And then the remainder of your high school career is going to be building off of that. And if you get a little practice now, boy, you're gonna be in a much better place as you go up the ladder in this discipline than if you hadn't had that practice. That's why we're doing it. All right, some of you, I think, already understand probably this video, which is outstanding since you just started studying algebra. All right, so where are we at? So how do I do what I just talked about? So y equals about 4 plus 5. Let's do a tripling function, and let's do x to the minus 7 over, let's make it 1900. Let's go years, x minus 1900 over 59. All right, so how would I do that? Do that quickly with this whole thought process of making zeros and ones, which is what this course is based on. All right, so I can immediately see that my asymptote is 4. I can immediately see that the user-friendly number is 1900, so I'll just put it here. I also know that I'm tripling, so I've got a certain altitude, and then the next one is 3 times that. So I got my picture, so I'm tripling in that direction, cutting things in a third in this direction. Nah, that's not too good. That should have come down more. And it happens over an elapsed period of time. So what are the two numbers, the x values that I'm looking at? Well, 1900 is one, and 59, so 1959 is the other. What's that going to give me? That's going to give me an initial jump at 1900. 1900 minus 1900 gets us 4 plus 5, 3 to the 0. Okay, so that 0 helps me because that becomes 1. So I have a jump of 5. And if I'm tripling, that should be 15 when I put it in. So 1959 minus 1900 is 59. 59 divided by 59, this becomes a 1. I still don't need a calculator for that at all. I've tripled the 5, and I got myself a nice graph. And now if I want to solve it for any altitude, all right, so right now let's put those numbers in. So this is y equals 4, the asymptotic behavior. As I keep decaying in this direction, I'm headed to 4. And another sip of coffee. Gotta have it, I could feel that I got too many numbers floating around in my head. That's good. Back to any altitude. So over here, we've got an altitude of 9, 4 plus 5. Over here, we've got 4 plus 15. That's 9. Here we have an altitude of 19, 15 and 4. I want to make sure I don't butcher this thing. And that happened in 1959. We had 4, 15, 19. Okay. And so, there's some number doubling 10, 10 and 4. There's a 14 in here. 14 is closer to the 19 than no, it's right in the middle. Is that right? If I go up 10 units, I go up 10 units from 4, I'm at 14. And 10 units doubles to 5, triples that. I don't feel like it's symmetric, and I feel like it looks that way. But I'm having that moment. So that's 4 units. That's fine. Okay, so I was a little closer to here if I doubled properly. All right, and so we want to find that x, which is number of years that gets us 14. Okay, and it should be an answer between 1900 and 1959. Should be an answer between those two. So let's find it. So I'm finding 14. Okay, again, should erase this, but I want you to see the picture. So we're going to get rid of the 4. That becomes 10. We're going to divide by 5. That becomes 2. We're going to undo 3 to the with log base 3. Now I have some students who do know what this is because it turns out it's the ln of 2 over the ln of 3, which is actually 0.7. We're going to learn these numbers, 1.1. All right, 7 over 1.1 is, maybe close to 2/3. So let's just keep that in mind. But that's an exact answer. And then I've got to multiply this by 59. Got to do 59. And then minus 1900 is positive 1900. Now I wished I had picked a nicer value here, like 3, right? But I didn't. So this is an exact answer. In the second half of the semester, we're going to talk about how we get a feel for that numerically. All right. So right now, if I had this times 59, We could do a little bit of this and see how close we get, just rough estimate. So this goes in about, oh, maybe 55 times. And if I multiply by 0.7, which is 7/10, 10 goes in 5.5 times 7. So if we do that, we got a 5, carry the 3, 38, 38.5. So rough estimate, I'm saying 1938.5. And boy, did I do a quick estimate there. But that year, then that year, then that year are certainly in the right order. Yeah, and I just did a really quick estimation. I could be off by 5 or 10 years, but I'd have to look at it more carefully to see if I'm off by more than that. Okay, but at least I got a feel for it. And that's what we're going to try to give you. All right, so there's a bit of rambling going on in this, but there's also a lot of seeds planted, a lot of things that I hope you know, even if you haven't processed them, you've heard of them. Which means the next time we talk about it, be a little further along, you understand a little bit more. And if we keep working with this now for another 30 or 40 days, I'm hoping that you pay enough attention that you actually learn what you're doing. But that's on you. You have to be the one to assume the position and think about what you're doing. And if you don't give it a thought, nobody can help you. Can't be done. You have to actually look at the problem and give it your attention. You can't do that if you hit your phone. I just want to get that one in there too. All right, so I'll post this and we'll be talking about these topics the remainder of the term.